Europe with the strongest connections with Iran is Italy. So it's great that we have you, Giuseppe, here. And the topic will be very interesting, especially for clinicians. It's from quantum physics to clinical hypnosis. It's a nice way. Please, Giuseppe, the stage is yours.
Thank you. Thank you. First of all, I wish to thank all the organizers, and particularly Benedittis, for the honor and the privilege of inviting me here in this wonderful country for the third time and the second time in Mashad. I would like to begin my lecture by sharing with you an important announcement and a recommendation. The current issue of the International Journal of Clinical Experimental Hypnosis has been just printed out, providing the state of art of clinical and basic research in hypnosis. I am the guest editor of this issue that has received so far positive and excellent reviews. I would invite you to take a look to this important effort to promote research in our field. Now, I will start by introducing some different points of view about reality. According to Martin Rees, the universe exists because we are aware of it, so because of consciousness or the observer effect. But Albert Einstein holds an opposite view. I like to think the moon is there even if I'm not looking at it, so without the observer. And according to Eugene Wigner, Nobel Prize 1963, it is not possible to formulate the laws of quantum mechanics without reference to consciousness. So there is a link between consciousness and quantum physics. And in the course of this lecture, I would like to propose a novel heuristic biopsychophysical model of consciousness based upon quantum mechanics, which can be the link between our brain, the hardware, and our consciousness or mind, the software. And the same model can be applied, in my opinion, to hypnosis, being a link between the hypnotic brain and hypnotic mind. So what is hypnosis? Hypnosis has been commonly defined as a special or altered state of consciousness. But despite an increasing body of evidence suggesting a rather discrete neural matrix for the hypnotic state and process, hypnosis is probably best explained by a more comprehensive model that takes into account many factors, biological, psychological, and social, the so-called biopsychosocial model. This evidence suggests which main factors contribute to the hypnotic experience, but tells nothing about the essence of hypnosis. So in order to understand what is hypnosis, we have to go back to consciousness, its definition and its theory. What is consciousness? Very difficult to answer this question. It is often pointed out that we can know of the existence of consciousness in no other way than through our first-person feeling of awareness or the second-person reports of others. And according to David Chalmers, consciousness is one of the most challenging and hard issues in science. There is nothing that we know better than a conscious experience, but at the same time, there is nothing more difficult to explain. Consciousness may be defined as a quality of mind that is generally associated with subjective experience, self-awareness, something happened, feeling, cognition, free will, and perception of relationship between us and our environment. In consciousness research, we have two problems, easy problems and hard problems. The easy problem refers to the main functions of consciousness, and neural studies have provided neural correlates of discrete components of conscious experience. But the hard problem is to explain ontological consciousness in terms of neural correlates. In a nutshell, the hard problem is explaining how the biological brain generates our subjective inner world of experience. And in my opinion, it is impossible to explain consciousness purely in terms of its neural correlates. how many types of consciousness we have. According to George Edelman, Nobel Prize for Medicine, we must distinguish between primary consciousness, which is the mental awareness of what's happening in the world, and superior order consciousness, or the self-consciousness, exclusive of human species and at some extent of primates. But which structure and functions of the brain are necessary and sufficient in order to give rise to consciousness and self-consciousness? Let's start with primary consciousness. We need thalamocortical system and projections, hippocampus, inhibitory circuits of basal ganglia, and the diffuse ascending system. But what about self-consciousness? We need again thalamus and thalamocortical network, but also the posterior cingulate cortex, the precuneus, the retrosplenial cortex, a high carbohydrate metabolism, and projection and coupling between brainstem and cortex. We can see here in the next slide the anatomical site. You can see the precuneus, which is a part between the parietal and occipital lobe, the posterior part of the cingulate cortex, and here the retrosplenial, which is behind the corpus callosum, and the high carbohydrate metabolism, which is needed. Other important aspects refer to quantitative and qualitative aspects of consciousness that can be exemplified as level of arousal on the horizontal axis versus representational capacity on the vertical axis. You can see we can go from brain dead to conscious wakefulness. What is the place of hypnosis in this metaspace? It's around here, because shows hypnosis a low level of arousal as compared with high representational capacity of consciousness, just similar to dream state. But what looks like a bat, or how the wetness of water is related to the structure of water? I'm talking about qualia, which has qualitative aspects of consciousness, or mental states quality of what it is like. For instance, the percept of feeling pain, painfulness, or seeing a red color, redness, or smelling a rose, and so on. Qualia are unspeakable, intrinsic, private, and directly and immediately apprehensible in consciousness. So, because the real essence of consciousness remains largely unknown, an amazing number of theories have been developed and proposed in order to answer the odd problem. Theories range from one extreme, which is Mysterianism, or the impossibility to reach any explanation, to the other, reductionism, or the mind as what the brain does. Other intermediate theories focus on functional or phenomenological determinants of the conscious experience. I want just to mention some of the reductionist paradigm of consciousness, such as Francis Crick's theory of 40 Hertz. According to Francis Crick, you, your feelings, your pain, your joys, your sorrows, your memories, your sense of personal identity, and your free will are nothing else than the behavior of a vast assembly of neurons and their associated molecules. And according to his theory, 40th Hertz synchronization in thalamocortical networks could give rise to a conscious experience. But how could this happen? Nobody can say. Another theory is the global workspace theory by French neurophysiologist Stanislas Dehaene. Consciousness is a form of information processing. It occurs when sensory data from an experience go to a global workspace and are broadcasting to other centers. Now, in studies of consciousness, reductionism argues that once the electrochemical neural correlates of consciousness are understood, there will be nothing left to be explained. But this theory tells nothing about the essence and the quality of conscious experience and the mind-body interface. So we now need to go back to a French philosopher of the Enlightenment, René Descartes, and its reductionist views of res cogitans, or the mind, and res extensa, which is the body, that is the mind-body interface. Now, nowadays, we think that neurochaos and quantum chaos may be considered as the bridge between Newtonian classical mechanics and quantum mechanics. There is an increasing evidence that many activities in the central nervous system are ruled by chaotic patterns. Modern trends in psychology and cognitive neuroscience suggest that applications of nonlinear dynamics seem to be particularly important for research on mind-brain relationship. Chaotic-like patterns have been found in normal and abnormal EEG, in electrophysiological studies in the olfactory groove in the rat, in epilepsy, in some kinds of neuropathic pain, and possibly in some dissociative phenomena such as in hypnosis. This slide shows one of the so-called strange attractor typical of chaotic patterns, the so-called Lorentz strange attractor. We have some other figure configurations such as the torus attractor in the olfactory groove of the rat, you can see here. Some other configuration of chaotic pattern of neuron action potentials. And this is my normal or abnormal EEG from a chaotic point of view, my personal EEG. A substantial body of evidence does not support the Cartesian dualistic model on both epistemological and clinical ground. Moreover, neuroimaging and hypnosis studies have recently shown how elusive is the borderline between real and imagined percept. As a consequence, the biomedical model and the current taxonomy seem unable to provide an adequate, descriptive, and explanatory model of the mind-body interface. In order to overcome the old and inappropriate dichotomy between body and mind, a novel heuristic model based upon chaotic complex system and quantum mechanics is proposed. This model postulates that brain activity and consciousness represent a chaotic complex system ruled by the probability principle as shown in quantum mechanics, rather than by the deterministic principle of causality. As a consequence, mind-body interface, sorry, it doesn't work. What happened? Just a moment. Okay. As a consequence, mind-body interface may be conceptualized as a continuum. So it is time to introduce you to the magic world of quanta, which is fascinating, mysterious, counterintuitive, but necessary, at least for subatomic world. The quantum enigma has challenged physicists for more than a century. Quantum theory postulates that atoms and molecules are not existing someplace until our observation creates them and there. We have some basic principles. Uncertainty principle, superposition, tunneling, the wave function collapse, quantum entanglement, and non-locality. I just want to briefly expose some of these principles. The uncertainty principle by Werner Heisenberg states that the measurement of certain system cannot be made without affecting the system, that is, without changing something in the system, the so-called observer effect. The superposition principle states that particles can make or inhabit 2, 100, 1 million things at the same time until observation occurs. And according to superposition, Schrödinger invented a thought cat experiment, very famous. A cat is sealed in a box with a flask of poison and a radiation source. If the source emits radioactive particle, which is 50% of chance, the flask shatters, releasing the poison and killing the cat. Quantum mechanics implies that the cat is simultaneously alive and dead in superposition until it is observed. But the act of opening the box collapses the superposition state, returning the cat to a classical state and making it either alive or dead. Tunneling is a wave function and means that electron can move through a barrier that it was not possible to move through to particles. And also the wave function collapse is important because observation collapses a wave function which can be in many states in a single state. So observation collapsed the wave function to a single particle. And also entanglement. Particles can be in two or more locations at the same time with distant connection, but only if nobody looks. And non-locality describes the apparent ability of objects to instantaneously know about each other's state, even at long distance. Now, according to quantum physics, what turns a wave into a particle is just observation. As a consequence, consciousness creates reality. And one of the most commonly known examples is the structure of light, because light is not made of structure really, but it's made of events. It's made of waves and of particles, the so-called photon. And at the same time, the light can be in the wave form or in the particle form, according to the Planck's constant. So they represent two aspects of the same reality. Now, there have been some attempts to integrate quantum physics, subatomic, to Newtonian mechanics to the classical world, such as the quantum loop gravity, or the string theory, or the gravitational waves. We have no time to get into details, but I want just to mention the gravitational waves, which were predicted by Albert Einstein 1 century ago. They are disturbances in the curvature of the space-time generated by accelerated masses that propagate outward from their source at the speed of light. These gravitational waves has been discovered recently, and three persons were awarded the Nobel Prize of Physics in 2017. Well, quantum gravitational waves may represent the missing link between the Newtonian classic world and the subatomic world. I don't know whether there is the sound, we can try. This is the sound of gravitational waves. I'm sorry, but no, doesn't work. Okay, believe me. You can hear the sound of gravitational waves from billions of light years. They have been recorded recently. But quantum physics not only applies to subatomic world, but also to macro world, in electrodynamics, for instance, in quantum biology. For instance, we have the first quantum computer that is able to produce an enormous amount of computation a second in particular condition. And it is inspired by quantum mechanics. But we have also some circumstantial evidence that several aspects of biological life might fit the principles of quantum mechanics. For instance, birds use quantum correlation to orient themselves in the space, the so-called magnetoreception. The proton tunnel effect in enzymatic reaction is a kind of quantum effect. Also, olfactory recognition is based upon quantum character, not made of particles, but of molecular vibration frequency that can change every second. Genes made of protons and genetic code are quantum mechanical entities, and mutation as a quantum leap of a gene, according to Schrödinger. Also, synapses may act as a kind of quantum physical action. Long-term quantum enhancement in the hippocampus, and we have some recent research showing that repetitive transcranial magnetic stimulation can act by means of quantum effects. So there are some evidence supporting the role of quantum physics in the macro world. Now, what about the quantum brain? There is some evidence showing that the brain can have some kind of quantum mechanics propriety. There is a quantum consciousness theory made by Ameroff and Penrose, and the pattern are that pattern neural activity correlate with mental states, synchronous oscillation in thalamus and cortex bind temporally information, and consciousness might emerge as a new propriety of computational complexity between neurons. How could this happen? Because neurons are made of a cytoskeleton and microtubules, and there is a possibly quantic organization in neuronal and glial microtubules. The tubulin subunits, which is made of protein, may act as qubits or basic information unit. When their computational ability reaches a high level of complexity, a preconscious event becomes conscious, and so self-awareness or conscious experience can arise. We can see here the microtubular structure of neurons and qubits and what may happen in synchronization in the brain of a rat as primary consciousness. But this theory has been highly controversial because substantially improved and because quantum mechanics does not apply to macrostructure such as the brain. But we can overcome these difficulties by a new discipline recently emerged, which is quantum cognition. Quantum cognition is an emerging field which applies the quantum-like paradigm to model cognitive phenomena such as information processing by complex systems such as the human brain. Since the use of a quantum theoretic framework is for modeling purposes only, the identification of quantum structure in cognitive phenomena does not imply the existence of microscopic quantum processes in the human brain. Now let's go back to the initial issue of hypnosis as a special state of consciousness and dynamic process. Quantum cognition and quantum chaos approaches can apply to a wide variety of hypnotic phenomena, such as analgesia, dissociation, amnesia, and also for pain. We know that the basic unit of information processing is a neuron, but a neuron cannot be in a superposition of two states. That means firing and not firing. Hence, it cannot produce superposition, playing the basic role in the quantum information processing. Instead, superpositions of mental states are created by complex neural networks of neurons. So quantum cognition states that the activity of such neural networks can produce effects which are formally described as interference of probability and entanglement. So if quantum physics cannot explain hypnosis because it cannot be applied, quantum cognition may be the link between quantum-like paradigm and the hypnotic mind. So quantum cognition paradigm postulates that conscious state may be conceptualized as a continuum spectrum. At one extremity of the spectrum, there is the superior order consciousness or self-consciousness associated with self-awareness, arousal, and a strong personality identity feeling. While at the other extremity, there are the altered or special state of consciousness, including hypnosis and meditative states, associated with dissociation, comfort, and effortless attention, with primary consciousness in between. Now, any particular conscious state, including hypnosis, at a given time is the expression of quantum probability differential and may shift from one extreme to the other without any problem, according to the quantum paradigm. So, two world events. One could be exteroception, which is body-oriented, and the other one is interoception, which is mind-oriented, are entangled and can shift at a given moment according to quantum probability differentials from one to the other, collapsing a wave function into a real actuality that may be physical and or subjective. So after the Tao of Physics published by Fyodor Capra in 1975, maybe that this new Tao of consciousness may open exciting perspectives in exploring the universe of human experience, including hypnosis. So quantum hypnosis, in my opinion, is a novel heuristic approach to hypnotic cognition and responses. It overcomes the limits and shortcomings of Cartesian dualism as well as quantum general theory. It applies to hypnotic cognitive functioning rather than hypnotic structure. And I want to finish to give some example of some translational techniques trying to transfer quantum cognition principles in quantum-like hypnotic procedure. Such as, for instance, we can translate chaotic pattern into confusion or maybe a shift in the slide, I don't know why, but we can read it anyway. The time-space continuum can turn into spatio-temporal dissociation and distortion. Mind-body continuum can be induced by mind-body dissociation and integration or reassociation. Superposition can be induced by suggesting multi-location and multi-temporal experience in a sort of a multiverse. Tunneling can be induced by means of a space-time tunneling or going through space and time barriers. An entanglement can be induced by distant spatio-temporal correlation and non-locality. And finally, coherence-decoherence can be experienced as unconscious mind, unconscious body interactions, and collapse mediated by the hypnotic observer. I think that this can explain how, for instance, some indirect Ericksonian technique based upon confusion and other characteristics can be explained their effectiveness in terms of a quantum-like paradigm. This is a new way, a new perspective from epistemological point of view. I would like to conclude by mentioning a visionary poet by England, William Blake, in the 18th century. It was inspired somehow by the quantum world, even though it was to come, to see a world in a grain of sand and a heaven in a wildflower, old infinity in the palm of your hand and eternity in an hour. Thank you for your kindness.
Thank you, Giuseppe. It was really nice to be here to learn a lot from you. Your presentations always have something new for everybody, especially for me. And now I think I should invite Dr. Mehdi Fatih for his live demonstration of hypnoanesthesia, which is always a very attractive part of our international congresses. Dr. Fatih, please.